G'day team, welcome back to another video on discrete modeling. Now we're going to jump away from the precedence networks and look at something called the Hungarian algorithm. Now we use this algorithm to solve large-scale assignment problems to optimize a situation. So there's a list of steps and they are a little bit confusing to start with, but we'll look at them when we apply them to a certain question. So before you even start, you need to check if we're trying to minimize or maximize the situation. If we are maximizing the problem, we take the largest element and subtract all other elements before we start step one. I've got a little example here. So this was my initial matrix. The largest element is 15. So I'm going to go 15 minus 10, which is 5. 15 minus 0. 15 minus 15 is 0. 15 minus 8 is 7. 15 minus 7 is 8. Now, this would be the matrix we use for the Hungarian algorithm. Because the Hungarian algorithm minimizes from the get-go, we need to inverse the matrix, which is what this process does for us. So, I'm not going to read through each step. I'm going to put them on the screen so you can have a bit of a read through. What I'll do is I'll do a question and explain what step I'm doing at that time. So, either write this down or take a screenshot, or flick back to this point and I can show in you can see what step I'm doing at the time. So let's get straight into a question. And now I'm going to make this question a little bit easier for us. I'm going to take out a factor of 10. Now this isn't going to change our answer and we'll bring in that factor of 10 later on. But just because we're going to try and do it quickly by hand, we're going to make the numbers a bit smaller for us. So we're going to go times $10 later down the line. So we've got Courtney, Dylan, Jessica, and Stuart, and they are sales representatives for a dairy company. The company needs to send each sales rep to either Cairns, Townsville, Hobart, or Geelong for specific conferences. Now, each person costs a different amount to travel to different cities depending on where they live. So let's have a look at a couple interpretational questions. So which location is most expensive for Jessica to fly to? So we go down, we find Jessica, look at her values, and we see that flying to Cairns would be the most expensive. Which sales representative would be the cheapest to fly to Hobart? Well, we find Hobart's column, look down, and we see $2.90 is the cheapest, which is Courtney. So Courtney would be the cheapest to fly to Hobart. So just a couple refreshing matrix interpretational things. Now we've got show that after steps 1 and 2 of the Hungarian algorithm, the reduced matrix is this. So again, let's just cross out a factor of 10 because it's not going to change our answer in the end. So let's apply step 1 and step 2. So what we first need to do is copy our table down into a matrix. So I've got 65, 50, 29, 16, 80, 68, 40, 35, 60, 45, 38, 25, 30, 22, 51, and 45. Perfect. So I've just copied all my numbers into my matrix. Now, step 1 is finding the minimum number in each row first and subtracting it from that row. So in this one, I've got 16. So I'm going to subtract 16. In the second row, I've got 35. The third row, I've got 25. And in the bottom, I've got 22. So we apply this and we create a new matrix. So 65 minus 16 is 49. 50 minus 16 is 34. 29 minus 16 is 13, and 16 minus 16 is 0. Now, we're just going to go through this process, 5, 33, and 45. Keep coming down, 35, 20, 13, and 0. And then we've got minus 22, so 8, 0. That's going to give us, math, 29, 45 take 22 is 23. Perfect. Now, step 2 what we do is we go through the columns and we subtract the smallest value in each column. So I'm going to subtract 8 here. I'm going to subtract 0. I'm going to subtract 5, and I'm going to subtract 0. So you can see we only need to do the columns that don't have zeros in them. So I'm going to put this up here now. So if I subtract 8 off of all of these, I've got 41. I've got 7. I've got 27, and I've got 0. I've got this column staying the same, 33, 20, and 0. Subtract 5, I've got 8, 0, 8, and 21. Then I've got this column being the same as well. So that's step 1 and step 2, and we go up and we check compared to the matrix they gave us, and with our crossed out zeros, we can see we got exactly the same. Now, how many horizontal and vertical lines are required to cover the zeros? Now, this is step 3, so we want to cover the zeros in the minimum amount of lines possible. So I'm going to get out another color, and I always start looking, can I get rid of 4 zeros? If not, then 3. If not, then 2, etc. So I can see I can get rid of these 3 with a straight vertical line here. Now, there's no other 3s, so I can get rid of my 2. And then I just get rid of my 1 here. Now, for the Hungarian algorithm to work, we need the same amount of lines as rows in my matrix. Now, I have 3 lines, but 4 rows. So that means I must jump to step 4, which means I identify the smallest value, which is 20, of the uncovered elements. So these 6 here that are uncovered. And what I'm going to do, I'm going to subtract 20 from these 6, but add 20 to the ones with intersections of lines. So I'm going to come down here. I'm going to do my subtractions first. So I've got 21, 14, that's going to be 17, 13, 7, 0. And then I do my additions. So 41 and 43. Now all the other numbers are the same. So 8, 0, 8, 0, 0, 0. We jump back to step 3 and try and cover the zeros again. So I've got my 3 zeros there. I've got my 2 zeros there. Now there's no way I can cover those 2 with 1 line. And now I have 4, which is super duper. That is exactly what we wanted. So I'm going to bring this matrix down here, and I'm just going to get rid of these lines here. So we now have the matrix set up that we can pick out our optimal solution. And I might move it over just a little bit this way. Now, hopefully you guys have played Sudoku before, and you know that we can't have the same number in a row and a column. So if I had a 0, well, technically a 0 here, I wouldn't be able to use this 0 or this 0, and I wouldn't be able to have a 0 in here. Now, that's the game we're going to play with our zeros. So I like to look in columns and try and find columns that use 1, 0. So I can see this 0 is the only one in that first column. So in our Sudoku way, we now can't use that 0 there, which leaves this one here to use, which also means I can't use that one. Now, this 0 is the only one in the third column, which means I can't use this 0, which means I have to use that 0 there. Now, this correlates to my optimal solution. So if I write in my order of names, so I go back up to my question, I've got Courtney, Dylan, so Courtney, Dylan, Jess, and Stu. And we're going to allocate where they are best fit, which is this highlighted spot here. Now, Courtney goes to the 4th town, which is Geelong. So Geelong. We've got Dylan going to Hobart. We've got Jess going to the 2nd one, which is Townsville. So TV. And then we got Stuart going to Cairns. And if we add up exactly how much each of those costs to go there, we will find the minimum cost for sending our 4 reps to their desired location. That there is the Hungarian algorithm. So thank you for watching, and I'll see you in the next video.